got some notes. Current lithium by end use. Okay, so we've got a pie chart here that breaks down what's being used for lithium, and what we want to remember is this lithium production levels. And here we are with the chart. About 450,000 tons were produced in 2009. Let's go back to our pie chart. So in 2009, the percentage estimates for pharmaceutical, since we just talked about that, let's look here. So for the pharmaceutical industry, approximately 22 million pounds of lithium was used, based on the chart here with the 450. Okay. Now let's look at air treatment. I'm not going to pump any conspiracy theories down your throats. This is just strictly what I pulled from the internet. Here's the Roskill Ltd. created this pie chart, tells you your breakdowns. So we've got 6% for air treatment. So that would be 400 out of 450,000 tons, 6%. That gives you 27,000 tons, which equals 67 million pounds used to treat air for lithium. Okay, now this other section right here, let's take a look at that. I've got it asterisked. Here's our asterisk. So other uses non-reported, we've got 168 million plus pounds. And one of the interesting things here is that lithium is a critical component in the combustion cycle for a hydrogen reaction, same as what our sun does to create the energy that it does, the fusion process. So for a hydrogen bomb, you need a significant amount of lithium as a byproduct that you utilize to get that explosive reaction going. So this is possible weapons of mass destruction production going on. And this was 2009. There's other pie charts that you can find, but nothing for current year 2019. So I had to go back to 2009 and look and get this information. Other things is sort of standard industrial. The battery, this is really taking over the pie chart because lithium batteries with the transportation initiatives and green energy storage.
So today, I'll tell you about the lightest metal on Earth, lithium. Lithium is the first group in the periodic table of chemical elements. Except for the smallest atomic mass, lithium has the lowest density of all metals, which is nearly 2 times lower than that of water. In appearance, lithium represents a shiny metal, which can be cut with a knife, but it will be required to exert sufficient force to achieve that. Lithium rapidly oxidizes in air, and while that is happening, it's being covered with a layer of oxides, carbonates, and lithium nitride black coating, because this is the only metal that can react with atmospheric nitrogen at room temperature. Lithium can be stored in kerosene. However, due to its low density, it will float on its surface. Now, shall we look at some of the chemical properties of lithium? A piece of lithium reacts rather calmly with water, forming hydrogen and lithium hydroxide. If you ignite the released hydrogen, the flames will turn beautifully red due to lithium ions. However, if we take lithium in the shape of thin lithium foil, which is used in lithium batteries, By the way, that will ignite and explode upon reaction with water, which is very dangerous. If you set fire to a little piece of lithium, it will melt and then light up with a very bright white flame, to then form lithium oxide during combustion. The temperature of burning lithium in the air is more than 2000 degrees Celsius. Lithium, as well as all other alkali metals, is an excellent reducing agent that easily loses electrons. It's surprising, however, that when it's melted at temperature above 300 degrees Celsius, lithium practically doesn't oxidize with the air and its surface remains glossy. If you ignite lithium on sand, it will react with the silicon that the sand consists of, forming an amorphous silicon. In addition, lithium reacts perfectly with sulfur. This reaction of lithium with sulfur formed so much energy that even ore can melted, on which the reaction was carried. And yes, I have also burned through the carpet with this reaction, but that is alright. I have many carpets. The other very dangerous lithium property is that when it starts to burn while being on wood, it will pick up oxygen from the cellulose molecules that make up the aforementioned wood. As such, lithium explodes, creating a lot of hot sparks. Don't try to repeat this experiment. Also, lithium can react with dry copper sulfate, recovering copper from its salt. These days, lithium finds many applications in science and technology. The most common use of it, of course, would be lithium-ion batteries and other power sources. Also, lithium is used in nuclear power, lasers, as well as metallurgy. Lithium compounds are used in medicine for the treatment of mental disorders because of its ability to be an antagonist of sodium ions. Subscribe to my channel to see many more of new and interesting.
Okay, thank you to Thoiso2 on YouTube, chemical experiments, for that video that we are using for the documentary. Please go to his channel, like, subscribe, support him. Looks like he's doing some good work. And now we'll continue on. We're going to get into some fairly technical papers on a couple of different things that they're doing right now with radio frequencies. And it'll probably take a little bit of homework to process all that. So let's get right into it. All right, so this is the end of our second video in a series. Our introduction was done. It's already posted. It's up. It's on YouTube. You can check it out. It's all about the medical lithium, everything around that, everything that surrounds the facts about human consumption of lithium, how it causes all these different health effects, and the toxicity and treatment levels with lithium are right next to each other. You can never know. It's all based on the individual, if they're actually getting treatment from it or having a toxic reaction to it. And part of the positive treatment factors that you can identify would be pretty much destroying your brain's ability to think, to be able to reason, to be able to be who you are. So in this second video, we kind of just summarized a little bit about how much lithium was produced in 2009, what it was used for, and what the chemical characteristics of lithium are. Thanks to the fellow YouTuber who did a great video. I enjoyed it. I thought it was cool. And in the next two videos, we're going to finish up this series. We're going to talk about the radio frequency technology. We're going to talk about how the lithium crystalline structures are, beneficial to radio frequency propagation and the terahertz pulse transmissions. I don't know if anybody is up to snuff on this stuff, but what it is talking about with this terahertz pulse transmission capabilities, utilizing lithium crystalline structures that are automatically being generated when this lithium is being dumped into our atmosphere. We talked about how there's over 67 million pounds of lithium being dispersed into the atmosphere as air treatment. We haven't identified the reasons for that. The information, the previous disclosures that were put out and were available several years ago about this are now gone. They're not on the internet anymore that I could find. Maybe they're somewhere. I'm sure somebody's pulled them and has them. I'd like to be able to get that stuff going and put it with this series so we could kind of be conclusive. But basically what it is that lithium has this characteristic of forming crystalline structures automatically in the atmosphere when it's put out there. And what they do is, because of the ability to release free electrons, they help to propagate radio frequencies at all kinds of different hertz transmissions at those different frequencies. They boost the signals, and that's why they're dumping it into the atmosphere. That's what they're utilizing it for, is to improve the ability to transmit electromagnetic signals, the RF radio frequency signals, which where I'm going to have to pull up a chart on the next video, and we'll have to talk about how radio frequency is just a part of the spectra of electron activity, electromagnetic activity. And what the lithium does is it actually offsets the valleys, scattering, when you're losing your electromagnetic force. The electromotive forces dissipate because they're creating magnetic fields. So what the lithium treatment does is it mitigates the loss of your electromotive force over a distance as it diffuses. It mitigates the loss of your electromotive force that was due to the magnetic field propagation. So it's very similar to DC current being transmitted over long distance. The reason why we don't use DC power in our electrical grid is because over distance, the electromagnetic propagation of magnetic fields dissipates, it saps the amps, the power, the electromotive force drops with distance due to those magnetic fields being propagated. So instead of maintaining the electromotive force in the amps over a distance, instead you get this propagating magnetic field over a distance, and your amps are dropping off in gosh, now I'm going to be stupid, I can't even think of the term, proportionally to, they're dropping off proportionally to the strengths of the magnetic fields being created along the transmission lines. So when you have a wire that's transmitting a direct current, along that wire, the magnetic fields being propagated are getting bigger and bigger and bigger, and the electromotive force being transmitted along that wire are becoming less and less and less powerful. So if you try to utilize DC energy over any sort of distance, if you're trying to create it, generate it in a generation station, and then utilize it at a distance away from it, there's going to be a tremendous amount of loss due to that magnetic field propagation. And the reason we use AC power, which Nikola Tesla knew was the answer way back when he was a freshman in learning physics, and when they only had little novelty style electric demonstration devices. he was shown one of these devices, and he raised his hand after the demonstration and said, "Hey, teach." This is obviously paraphrased. Don't you think that there's a way that we could get rid of all that nasty, dirty brush, all that plasma generated? He didn't. I don't think he phrased it like this. All that loss of electromotive force due to the plasma generated between the brushes and the motor aperture itself. And the teacher said, "No, you're a total friggin' idiot." And he said, "Well, if you had a pulse, a switching pulse for this motor, then you could. It would work very well." So what we're going to talk about is how this terahertz pulse transmission work is basically creating radio frequency signals equivalent to alternating current. So instead of there being the DC style radio frequency fields being broadcast from an antenna and received by an antenna, being broadcast from a transmitter and received by the receiver, what they're doing is they're creating an AC style radio frequency propagation network and boosting the valley scattering. They're mitigating the losses in the valley scattering with the lithium. So that's what's going to be happening. And right now, the lithium is being used to increase the ability to spread the signal. That the radio frequency signals they're going farther with more electromotive force because of the introduction of lithium and the way it reacts and makes a crystalline structure naturally in the atmosphere. So we've already, I think, looked at in that video, the upcoming videos, we're going to have the lithium iodide analyses that they did, and we're going to look at the lithium, nitrogen, oxygen molecule crystalline structures that are naturally created. We already know that for the 5G signal signal propagations, what we have in the short distance of this type of stuff in the 60 hertz range of radio frequency broadcast is about a 98% oxygen saturation rate with these signals, which turns that oxygen into a molecule. The O2 is a molecule that is no longer able to be metabolized through the biological systems that we have and other life forms have. Anything that's utilizing its lungs to breathe. And I believe this effect is even worse, actually, in salinated water. So the oceans would actually be at a higher susceptibility to the radio frequencies in the 5G ranges if they're being broadcast into the water, where the oxygen will not be able to be absorbed by biological life forms that rely on oxygen for the metabolism and the life force that they have. So in our blood, I know I already touched on this in the last video, the first introduction video. What I did say is that the cerebral fluid and the spinal fluid is a glucose-based fluid, where our blood is actually a sodium-based fluid. So it's a saline type solution, a salt water. It's a salty liquid, our blood. So what we want to do is take a look at how the radio frequencies are going to be boosted by the lithium crystalline structures that are naturally propagated when lithium is broadcast into the atmosphere. And part of that is one of these papers that we've got. I've got to rework this video because my reading, the read aloud computer voice that you can get to go just did not pick up on my microphone well at all. I'm working on it. I'm brand new to this. I've been doing this screen capture videos for less than a week. So I apologize if they're crap. Give me a thumbs down, give me a comment, let me know, tell me what's going on, so that way I can try to make it better, or just tell me to shut up. I'll get off YouTube, you know, if you hate it. I think I've got 3 subscribers. It's pretty pathetic, you know, but I've only put videos up here since January, and the first 2 videos were PowerPoint presentations that I made about economic development, and I want to do some audio in addition to those so I can walk through and explain it, because I've got some feedback from a couple of friends that said those videos are just completely undigestible. The PowerPoint presentations, when I printed them out and handed them out to people, they said, right over. If I had somebody talking me through it and slowing it down where it's digestible, then you've got some good information probably. And so that's what I want to do with those. They were based on some studies that I did, and I think there's good information. But okay, we're already going longer. But I look forward to part 3 and part 4, where we're really going to wrap this thing up, and we're going to show how putting lithium into our atmosphere actually can double the propagation effectiveness of the electromotive force and mitigate that electromagnetic field propagation that would sap the electromotive force. So when you create more magnetic field, you lose your electromagnetic force. So what's going to happen is the radio frequencies are going to start utilizing the lithium crystalline structures that they'll actually assist in propagating when they're being broadcast, and they will improve the signal strength, the electromotive force of the signals and data transfer of these different hertz frequencies. We're going to look at the 60 hertz. 60 hertz is what we use in our power grid as well for the transmission line transmit electromotive force of AC. So what they've done is they're going to use the terahertz pulse transmission, and with the addition of the lithium will mitigate the scattering effect of the valleys, and it also redoubles and creates the AC effect, where instead of just the one wave, now you've got the counter wave on the bottom, because your lithium is reflecting it because of all the free electrons able to be broadcast. So just really interesting, absolutely awesome type stuff going on. As far as what it has to do with human health, we've got the direct lithium that was covered in the first video. The introduction video is the medical lithium information, letting you know what it does, and it mimics several diseases, and we'll talk a little bit more about that as well as we wrap up this series for the documentary. Thanks a lot. Best of luck. Take care.